So good day class. So today we're going to discuss about the drainage system first before I'm going to show you a layout of a plumbing plan because I think not all of you were under me during your building tech book. So I think some of you told me that that you were not able to draw a plumbing plan in your building tech book. So we're going to address that issue later on by I think I'll just make you copy the plan or make you do a different activity. So let's uh, cross the bridge when we get there. But first, we're going to discuss about the drainage system. So these are the subsystems of the sanitary system. We have the soil drainage system, which contains the fecal matter. The waste drainage system, which contains the sanitary waste, except from uh, the those containing fecal waste. Then we have the storm drainage system, which is the water coming from the rain and other sources. Then you have the vent system, which provides um, the ventilation for the different subsystems. Okay, so it prevents backflow and the rise of bad foul odor from the fixtures. So first, this is the soil drainage system. So it is the piping that conveys the discharge of water closets or fixtures having similar functions containing fecal matter with or without the discharges from other fixtures. So this is an example. This is an example class. Okay, so this is a what you call a plumbing isometric. This is the water closet. Okay. And this is a drainage system which ultimately connects into the STP or septic bowl. Okay. Then we have also have the waste drainage system or sanitary drainage system, which is the piping that receives the liquid discharge from plumbing fixtures other than those fixtures receiving fecal matter. So this piping is free of fecal flow. So this is the keyword here, it's free of fecal flow. Then you have the storm drainage system, which is the piping system that receives clear water drainage from leaders, downspouts, surface runoff, groundwater, subsurface water, condensate water, cooling water, or other similar discharges and conveys them to the point of disposal. So all sanitary wastes must be excluded. Then we have the vent system, which is the piping system that receives a flow of air to or from a drainage system or to provide the circulation of air within such system to protect trap seals from siphonage or back pressure. So the purpose of your vent system class simply is to protect the trap seals. So these are the general requirements of a properly designed drainage system. Part of this you can get from the National Plumbing Code. So let's try to tackle some of the points raised here. One, the piping must be airtight, gas tight, and watertight. And each plumbing fixture, except those with integral traps, shall be separately trapped by an approved type water seal trap. So this is to prevent odor from rising from the drainage system and contaminating the surrounding air in the room. So if it smells bad, class, there's a possibility that the water seal trap is compromised within the system. So each plumbing fixture trap shall be provided with vent pipes. This is to protect the drainage system against siphonage and back pressure and to assure air circulation throughout the drainage system. When you have a clean out. Clean out is easily accessible, shall be provided for inspection or cleaning of the pipe. So this is what you're going to provide last to make sure that your pipe could be maintained. So you need a clean out. So I'm going to show you a drawing of this later in our plan. So the location of the clean out shall be at the upper end of every horizontal waste or soil pipe. So at every change of horizontal direction of not more than 22.5 degrees within a 1.5 meter inside the property line before the house sewer connection. At every 15 meters to a horizontal run of a soil or waste pipe, then all horizontal piping shall be in practical alignment and at a uniform grade of not less than 2% or 2 centimeters per meter towards the point of disposal. Then all horizontal piping shall be supported and anchored at intervals not exceeding 3 meters. Then vertical piping shall be secured at sufficient close intervals to keep the pipe in alignment. So stacks shall be properly supported at their bases. So your plumbing layout class, this one, the general requirements, you're going to write this also in your plumbing plan. The contents of these, you can base them on the sanitary code or the national plumbing code. Is there a national or the plumbing code? I'm not so sure if there's a national plumbing code. I think you should refer to the sanitary code of the Philippines. And then let's go to the definition from the national plumbing. There's an NPC 1999 edition, national plumbing code. So these are the definitions. What's a house? A building drain. So it's part of the lowest horizontal piping of a plumbing system, which receives the discharges from soil, waste, and other drainage pipes inside of a building and conveys it to the house sewer outside the building. So that's the definition of house building drain. So what's a house building sewer? So it extends from the house drain at a point 0.60 meters from the outside face of the foundation wall of a building to the junction with the street sewer to any point of discharge and conveying the drainage of one building site. No house or building sewer shall be smaller than 150 millimeters in diameter nor less in size than the house building drain. The waste pipe is defined as a something that conveys waste water or liquid waste free of fecal matter. Then a soil pipe, any pipe which conveys the discharge of water closet, urinal, or fixtures having similar function, with or without discharges from other fixtures to the building drain or building sewer. Then we have a soil stack pipe. It's a vertical soil pipe conveying fecal matter and wastewater. And you have a vent pipe. It is used for ensuring the circulation of air in a plumbing system and for receiving negative pressure exerted on trap seals. Then you have a vent stack. It is the vertical vent pipe installed primarily for providing circulation of air to and from any part of the soil waste of the drainage system. You have a septic tank, a watertight covered receptacle designed and constructed to receive the discharge of sewage from the building sewer, separate solids from the liquid, digest organic matter, and store the digested solids, the clarified liquid to discharge for final disposal. So I think most all residential buildings last should have a septic tank. Then we're going to tackle this in detail later on as we progress through our course. Then you have a private sewage disposal system, which is a septic tank, the effluent discharging into a subsurface disposal field, sewage pits, or of such other facilities are may permitted by the plumbing code. You have the roof gutter, so the water collector at the eaves of the building. You have a downspout, a vertical pipe which conveys rainwater, also known as a conductor or rainwater. Then you have the storm drain, receives stormwater, clear rain or surface water waste. Patch basin, so it is a receptacle in which liquids are retained for a sufficient period of time to allow materials to settle to deposit. They have a trap. It's a fitting or device designed and constructed to provide, when properly vented, a liquid seal which prevents the backflow of foul air or methane gas without materially affecting the flow of sewage or wastewater through it. Okay, so these are the materials used for the drainage piping as approved by the National Building Code, Plumbing Code. First, you have the cast iron. Second, the ductile iron. Then you have galvanized steel, which will not be used underground. It kept at least 152 mm above ground. Then the galvanized wrought iron. Should not be used underground, kept at 152 mm above ground. You have the lead, copper, brass, series 1000, PVC, DMV, extra strength, vitrified clay pipe, and approved material having smooth and uniform bore. So, according here, note ABS and PVC DWV can be used in high-rise buildings at the discretion of the RMP and with the full consent of the owner. So these are also the different pipes. Okay. For the vent stack, you can use copper, cast iron, but the most popular now is PVC for everything, except for the downspout. Oh yes, downspout also. You can use PVC. So I seldom see in actual applications less those who use cast iron or brass or copper or lead. So these are the grades of horizontal piping. So all horizontal piping shall be run in practical alignment and at a uniform grade of not less than 2% or 20 mm rise per meter length. So, and shall be supported or anchored at intervals exceeding 3 meters. So all stacks shall be properly supported at their bases and all pipes shall be rigidly secured. So 2 inches rise per every 100 inches length. So a soil branch having a pitch of more than 2% has the tendency of waste separation. So the water flow faster and heavy suspended materials are left and deposited at the bottom of the pipe. So look at this example class. If it's too horizontal, then there's no flow because there's no slope. Okay? But if you have a 1/4 inch to 1/2 inch, okay, this is correct because there's flow. So this is 2%. So you just have to tilt it a little bit. But if you're going to tilt it too much, what would happen is that the water will flow, but the waste is left inside the pipe. So you have to be careful in grading your piping the plumbing system of your houses. So every change in direction, so all changes in direction shall be made by appropriate 45 degrees wise, half-wise, or long sweep water bends, except that single sanitary tees may be used on vertical stacks, and short water bends may be used in soil and waste lines, where the change in direction of flow is from horizontal to vertical. Tees and crosses may be used in bent pipes. So these are examples of prohibited fittings. Okay, you have the double hub, ways to fixture drilling or tapping connection. Then you have the double T. Okay, so traps were required. So each plumbing fixture requires traps. So only one trap shall be permitted on a trap arm. Then one trap centrally located may serve three single compartment sinks or laundry traps or lavatories adjacent to each other in the same room, where the waste outlets not more than 0.75 meters apart. So the size of traps. So the trap shall be the same size as the trap arm to which it is connected. Then each fixture trap shall have a trap seal of water of not less than 51 mm and not more than 102 mm. For the installation of traps, the developed length of the trap arm measured from the top of the closet ring to the inner edge of vent of a water closet or similar fixture should not exceed 1.8 meters. Then for trap arm, 76 mm diameter or larger, a cleanout is required for a change of direction of greater than 22.5 degrees. Okay, so these are the types of permissible traps. So this is a deep seal P trap. Okay, so it looks like a letter P here. So the water seal is about twice the size of the common P trap. Okay, it's used for extreme conditions because resealing quality is greater. Okay, this is a stand trap. So used for fixtures as a slop sinks that are usually built low in the ground, leaving very little space for foundation and a trap. So serves as a water seal and structural support for the fixture. So this is also made of strong materials because it could also serve as structural support. Okay, we have here the running trap, which is used within the line of the house drain. So look, if you look at this last, this trap is just shallow. Then you have the drum trap. I think this is used in bathtub and in some smaller swimming pools. There's a large diameter, 0.16 meters. Then it's used for fixtures that discharge large amount of water, bathtubs, shower, or floor drains. So this is a trap seal, your drum trap. Okay, for the installation of traps, the vertical distance between a fixture outlet, tailpiece, and the trap wear should not exceed 0.60 meters in length. So the horizontal distance of trap arms, the trap arm diameter of 32 mm, so it's corresponding 0.76. At 38 is 1.07. At 51 is 1.32. At 76 is 1.83. And 102 is 3.05. So for the requirements of clean out, so it's at the upper terminal of every horizontal or sewer waste line. So at each run of piping more than 15 meters in total developed length of at every 15 meters of total developed length of a fraction thereof, additional clean out shall be provided on a horizontal line with an aggregate offset angle exceeding 135 degrees. Inside the building, near the connection between the building drain and the building sewer, or installed outside the building at the lower end of the building drain and extended to grade. Then, cleanouts are not required on a horizontal drain not less than 1.5 meters in length unless such line is serving sinks or urinals. On short horizontal drainage pipe installed at a slope of 72 degrees or less from the vertical line or at an angle of 1/5 bend. So a vent pipe is a pipe or opening used for ensuring the circulation of air in a plumbing system and for relieving the negative pressure exerted on trap seals. So these are the main types. You have the main soil and waste vent, the main vent, individual vent or back vent, the unit common or dual vent, a relief vent, a yoke or bypass vent, a circuit vent, a loop vent, a wet vent, a dry local vent, a dry vent, a stack vent, and a vent stack. So, okay, so this is an example of the main soil and waste vent. So it is the backbone of the entire sanitary system. It's connected to the main soil and waste stack. So the portion or waste does not travel through and continues to the roof. The portion penetrating the roof is called the vent stack through roof or VSTR. Okay, so your vent glass, it's important because it provides a circulation of air which is needed in your uh, soil and waste system. So if it goes above the roof line, we call that the VSTR. I'll try to show you an example later if I can find one in the plans that I have. Okay, and you have your main vent here. This red line is the principal artery of the venting system, which is which vent branches are connected. It's also called the collecting vent line because all the other vents are connected here. You also have the individual or back vent, so it's a pipe installed to vent a fixture. Trap that connects with the vent system above the fixture served or terminates in the open air. So the sizes for lavatories is 1 to 1.5, the sink 1.5, the shower laundry slab sink 1 inch, the water closet 3 inches. Okay, so this is an example of it. Okay. The individual vent goes to here. Then you have a unit, common or dual vent, because it serves as the vent of two lavatories here in this example. It's a one vent pipe serving two traps. So these are the traps. This is the venting system. Then we have a relief vent, which is a vertical vent line that provides additional circulation of air between the drainage and vent systems or to act as an auxiliary vent on a specially designed system such as a yoke vent or connection between the soil and vent stacks. This is the relief vent class, okay, and goes here to the main vent, but it is not connected here. So this is a separate line. Here the clean out. Then you have what you call a yoke or bypass vent. So it's a pipe connecting upward from a soil or waste stack below the floor and below horizontal connection to an adjacent vent stack at a point above the floor and higher than the highest spill level of fixtures, preventing pressure changes in the stacks. Then you have what you call a circuit vent. Is a group vent pipe which starts in front of the extreme fixture connection on a horizontal branch and connects to the vent stack, which is also called the loop vent. So it serves a battery of fixtures. So this is the stack. Here we have the circuit vent, and you have the vent here and the main stack. So this stack class, I think this is where the waste flow. So it's separate from the venting system. Okay, then you also have a loop vent, so a vertical vent connection in a horizontal soil or waste pipe branch at a point downstream of the last fixture connection and turning to a horizontal line above the highest overflow level of the highest fixture connected there. So it's used in spaces without partitions. Then we have here a wet vent. It's the portion of the vent pipe through which wastewater also flows through. So if wastewater also flows through it, you can call that a wet vent. Okay, so this is an example of a wet vent. So it's a ventilation system, but there's a chance that it could also water could also flow through it. Okay, then you have a local vent, is a pipe or shaft to convey foul air from a plumbing fixture or a room to the outer air. Then you have a dry vent, a vent that does not carry liquid or waterborne waste. And you have a vent stack, the vertical vent pipe installed primarily for providing circulation of air to and from any part of the soil, waste of the drainage system. The uppermost and above the roof has traditionally been referred to as VSTR or vent stack through roof. Okay, so let's stop our lecture here and I'm going to show you an example of a plan. So this is something that we're uh, we're working currently. So this drawing is done in AutoCAD, but since you don't have this subject yet, you're going to do this manually. So in most drawing plans class, it's usually done in a single line. But if you could do it like this, then it would be easier for the owner to understand your plumbing layout. Okay, so for example here, so you have a reducing T. Then for every change in direction, okay, we use this pipe. Then a clean out there for cleaning it. Okay, before it goes to the catch basin. So your catch, this is the catch basin class. This is a drawing of it. So the catch basin, water from storm drainage, from the storm, from the rain, it usually flows through here. Okay, so this is an example of a soil pipe. As you can see, this the the kitchen is drawn in hidden lines because the soil pipe it does not collect waste uh, from your kitchen. It only collects waste that have fecal forms in it. then directly goes to your septic vault. Okay, so these are some of the details. So every change in horizontal direction, so this is the drawing. So you have your clean out, the PVC Y, and then the PVC drain pipe. This is the floor clean out example. Okay, so let's move into the other details. So this is the details of Petra. This is the clean out here. Okay, it's also a sample of a wall clean out. So this is an example of a venting system. So if you want to copy this class, just simply do a screenshot. Or stop the video, then do a screenshot. It's as easy as that. Okay, so let's move to other examples. So this is an example of a plumbing system. So this is from a project about a year ago. So first, you'll need to make a legend. So let me move the viewport a bit. As you can see. So the legend class, you're going to write what the line represents. So for example, in this drawing, this line here represent a 4-inch diameter soil line. This line represents a 3-inch diameter waste line, and this line represents a 2-inch diameter vent line. So it's like this, and this is a propylene water line. This is for WC is for water closet, F is for faucet, CO is for clean out, FD is for floor drain, lab is for lavatory, KS is for kitchen sink, GV is for gate valve, CV is for check valve, SH is for shower head, VTR is vent through roof, HB hose bib. So when you say a hose bib, it looks like your regular faucet, only that you can install a hose in it. And you have a CB or catch basin, and you have the DS is a downspout. So let's look into the water line layout. This is an example of a water line layout here. So since this is a much bigger project, so our sanitary engineer uh, made blow up plans for this. So you can actually see this is the hose beam. So it's just a single line. So the gate valve here is a lavatory, a water closet, and a shower. So it's just the water line system throughout the uh, project. So I think it's easier to lay out your water line because these are just straight lines, but you have to familiarize yourselves with the different symbols. Okay, so usually a 1/2 diameter or 3/4 diameter pipe is used for this. Okay. So this is the diagram from the water source. From the water source, you need a gate valve. Before it goes to the meter, then you have a check valve, then you have a gate valve again here, before it provides water to your building. Okay, so this is the water source class. Travels here, you have a riser if you have a second story, or if it doesn't have a second story, just simply connect it to the rest of the system. So we have a water supply layout 1 here. Then we have a water tank here to service the facility. So it is a water tank on the roof deck. So you have a pump here in the riser. So this is an example class of an isometric water line isometric. So this is the water source. You can see it goes up, water tank, riser, then goes down. The significance of the water tank is that if there's no the water pressure is low from the main source, then you could just use the water that is stored in the water tank to provide water to the rest of the system. Okay. Here you can also see uh, the water closet, the and other fixtures as well. You can also add some details. So these are not architectural details. This is prepared by a sanitary engineer. This is a plumbing layout. So a waistline. This is an example of a waistline layout class. Let's magnify this a bit. So as I said in an earlier lesson, so if you say the waistline layout, it's a waste which does not contain fecal matter. This is an example of it. So we use some 2" and 4" PVC pipes. Every change of direction you have Y. Okay. This is for the floor clean out. So there are connection from the horizontal to vertical. And this is the plumbing isometric. So in your plumbing isometric, you just have to draw the floor plan of the house in an isometric manner. Then you're going to draw the different pipes in the system. Okay. So if you're going to submit to my class a plumbing system that you're going to design, I'm going to check if your layout is correct and if you place the correct piping in your drawings. So this is an example for a single line diagram. Now going back to our AutoCAD model, I prefer I would prefer class that if you're going to design your plumbing system that you draw it in this manner. But don't worry, I'll try to adjust the scale and scope so that you won't use much resources on this project. So I understand that this is we're still in the pandemic season and some of you might be struggling with the materials. What's important is that I can see that you have learned how to lay out and design the pipes, your plumbing system. Okay, so this is a much better layout compared to having a single line diagram, but this is very uh, tiring to draw. So you really need a lot of patience and you need to be detail oriented. This is good for small projects, but if you're going to do this in large projects such as what I have shown earlier, it would really take time and a lot of concentration and skill. Okay. So we have a separate plan for the waistline. Let's go to here. It's the storm drain layout. So it's basically the water coming from the rain, the gutter. So it goes to your storm drain, drainage system, catch basins before it will be finally discharged to the public drainage. So this is an example of a catch basin. So what you can see here, this is the size, it's the manhole. This is the uh, 6" diameter pipe. Okay, this is the inlet pipe. Okay. Now we're finally on the detail for the septic tank. So septic tanks class, I think the requirements now for subdivisions is the 3-chamber. So this is the detail of a 3-chamber septic tank. Okay, so this is an example class of a septic tank detail. So this is one of the details that you're going to draw in your plumbing plan. So this is really important. Okay, this is the plan. So there are 3 manholes for it. Okay. Then, of course, you're going to place your legend. So remember these terms when you draw your uh, plumbing plan. So the general notes, you can write this. For example, all plumbing work should be under the direct supervision of a licensed master plumber. Then tank must be built watertight to concrete, stone, or CHP. But I think you can make your own class, but it should be based on the uh, plumbing code or national plumbing code. So these are the examples of the kind of drawings that you're going to place on your plan. So naturally, class, if you're just doing a small residential building, so it won't be as complicated as this one. All you have to do is write the general notes, going to make the plumbing plan, plumbing isometric, then you're going to have a location map also. So these are the things that you're going to need in order to draw a good plumbing plan. So like what I've said earlier, you can do a one line drawing, but if you could produce a drawing which shows in details the pipes, such as this one or like the what I have shown you in the AutoCAD earlier, it would be much better. Okay, so I think I have left the instruction for our activity for this week. So if you have any further questions or clarifications, don't hesitate to reach me online. I'll try to answer your questions and queries as long as I can see them. Okay, so stay safe, class, and see you next meeting. If you really have questions, class, honestly, I'll return this again. Please ask so that I can facilitate your questions. Anyway, our PIT, I'm going to give sufficient time for it to complete. Then we'll do some drawing exercises. Okay? So in our drawing exercises, maybe I'll let you draw the septic vault or section of the septic vault or its plan or section, the catch basin. And when you already are familiar with the different drawings, you can integrate that in the plumbing plan. Okay, so see you next week.